So we're going to look at, there's 4 different ways that we're going to look at how to calculate the area under the curve using Riemann sums and also trapezoids. I don't know which ones you guys have used before. Have you used all of them before? Okay, good. And this should be reviewed. We can go through pretty quick. There's 4 ways. We're going to look at all 4 ways, and I'm just going to keep changing this to the correct spelling. Okay. The first way that we're going to look at is trapezoids. And trapezoids are nice because you kind of get that angle that gets kind of close-ish to the curve, whereas with all the other ones, they're rectangles, and so it's always a severe, not severe, I guess it just depends how wide the rectangle is, but they're often pretty severe overestimates or pretty severe underestimates, the rectangles are. If you have the width small enough, and we're going to talk about that later on here in different units. If the width is small enough, obviously it's accurate, okay? And then the other 3 are areas of rectangle. Put them all up there, okay? So your areas of the rectangle, whether you're using a left Riemann sum, a right Riemann sum, or a midpoint Riemann sum. These are the 4 ways you're typically going to hand calculate the area under the curve, which is finding the integral. You'll want your book open because we're just going to go through different examples. I'm not going to do one of each, but we're going to do a couple. Okay. Yeah. So the first we're going to do is this one. This is on page 141. This is midpoint. I want us to work on midpoint. All right. And so they've created the drawing for you already. They told you how many rectangles, and they've shown you how many rectangles you're going to calculate the area of. And if you notice here why this is a midpoint, okay, they give us the values. That's really important too. Because what we need to know is since each width is 2, that every 1, so 1's a midpoint here, 3's a midpoint here, 5, etc. So what they're telling you is the corresponding y that goes with 1, 3, 5, 7, and 9 are the ones you need, right? Those are that's telling you the height of the rectangle. Okay, so go ahead and just calculate the area of all the different rectangles. Okay. And let's see if you can calculate area. Let's see if I did it right. Scary stuff here. Here's what I did. So one of the things that I like about doing these kinds of things is because the width is going to be the same every time. 2, 2, 2, 2. So if all I really need to do is worry about the heights. Now, obviously, this means 2 times 2. So there's the first one. And then this one is 2 times 5. And this one is 2 times 3. This one is 2 times 1. This is 2 times 3. So the thing about Riemann sums that typically is not typically. It's if the width of the rectangles are all the same, you can shortcut it a little bit, right? If the widths are not the same, then you have to technically write out all the individual areas. But since these were all the same, that's why I chose to do it this way, right? And then that's, again, here's if you wrote out each rectangle, 2 times 2, 2 times 5, 2 times 3. Obviously, they're both the same thing, okay? And you should have gotten approximately 28. Now, you say, why are you saying approximately? That's obviously that you do those calculations, it absolutely equals 28. Why am I saying approximately equal to 28? Yeah, because our rectangles are an approximation of the area. We have a lot of spots, like right here, there's a spot missing that's not covered, another spot that's missing, another spot that's missing. And then we have overs, right? We have an over amount here, an over amount here. This is not under the curve. All these are over estimates. So that's why we say it's approximate. And if we knew what f of x was, of course, we could figure out what the actual area under the curve was. But that's what we're doing with that one. Okay, any questions about the midpoint one? Let's do a left or right. I don't remember which one I set up. Okay, it's a left. Same page, example 2. Okay, a left. And the same 0 to 10. 5 rectangles. 5 rectangles again. Okay, so this time I want you to just draw them also, and then calculate the area. Here are the rectangles I drew.
Oh, yours are perfect.
I made them colorful. Now, obviously, this first one is not a rectangle, okay? But when you use the left Riemann sum, you're taking the value to the left. And so, since my increments are of 2, I start at 0, 2, 4, 6, 8. There's not a 10. If it was a right Riemann sum, then I would be starting up here, and we would go from whatever the 10 value is. But since it's a left Riemann sum, when we're looking at this interval, I'm going to look at this one since there's not a 0 here. From 2 to 4, in this case, actually it's a bad example because the right and left are the same. 4 and 6, let's look here. If I used a right Riemann sum, the top of the rectangle would be here, right? Because where 6 is the right edge of this interval, I draw my rectangle, okay? And then from here, it's just a matter of doing the calculation. I wrote it all out this time. This one obviously has no area. This is 2 times 4. This is also 2 times 4. This is 2 times 2, and this is also 2 times 6. So that one gives us 24. And we could, discuss which area is the better approximation, this one or the midpoint one. We could discuss that, and we could look into overages and underages. Why isn't that a word? That's definitely not a word.
Is that a word?
Overage is definitely a word. Underage should be a word. If overage is a word, yeah, it is.
Underage.
Underage. No, because then it's underage. Yeah, different thing.
Well, but overage is no.
Yeah. Okay. Oh, I did give you a right hand one. I lied. I'm sorry. I gave you a right hand one. However, this time the intervals are not equal. This is example 5. So we are going from the right, and we've got some negative values, so watch out for that. Give that one a shot. That's my rectangles. And yes, I colored them again. Okay. Hopefully that's what yours look like. Okay. We're from, and since we're talking about right ones, and from -4 to 10 is a little tricky, right? Because this curve is kind of increasing barely. So it doesn't seem like there's any space here, but if I had the ability to really zoom in on the rectangle and this line, there'd be a little bit of space here because as the right-hand side, this value is greater, because it's negative, than this. So there would be some space here, kind of like you see the space here, okay? And then again, you're going from the right, from 2 to 3. 3 is again that 0, and then the right value for 5, and that's going to go there. So again, with the right hand Riemann sum, this first one is being left out, but we're using the other ones. In the left hand one, the last one was left out, and we used these. Okay? And then they gave us the formula, so it's just a matter of plugging in -4, 0, 2, 3, and 5. Okay. So here's what it looks like all written out with all the work shown. Right. So this interval here is 6x is 6. Here x is 4. Here x is 2. I didn't even bother. It's just 0. And then this x is 2. And then to find all the corresponding y's, you just have to plug the right value in. -4, 0, 2, and 5. So it's just a matter of simplifying this. And
we can stop there. Like on the test.
yeah, so on the AP exam, if you show this, then you're good. Then you can do all the rest, hopefully, if it's a calculator problem in your calculator. And just be sure to include the original integral, because that's what we're trying to find. I think one of the things that I'm starting to see more and more about grading criteria is making sure that you have equations that are equal to each other. And so when you decide to put an equal sign or approximately equal to, that we have a two-sided thing. Anyway, this ends up being negative 35.625. So I guess I used the calculator, must be. But if you didn't use the calculator and you left it as a fraction, I can tell you that this is also equal to negative 35 and 5/8. I'm not going to try to tell you what it is as a improper fraction. Never mind, I will. Negative 285 over 8. I can't help myself. All right. Okay, last thing to look at. I like looking at the trapezoid one because, again, I think that now in this, bless you, in this example, we've got a little gap here. We've got a huge overage here. But if you use the trapezoid, you kind of snake that diagonal of the trapezoid almost like a tangent line. So you get closer to the curve with trapezoids. But here is the formula in case you do not know the area of a trapezoid. And then I'm going to show you why this formula exists. Maybe you've never seen it before. I'm going to show it to you. I'm going to show you why this is the formula. Okay? So, I wish I would have. All right, I'm going to put it together. Okay, here are two trapezoids, the same trapezoid. It's the same trapezoid, okay? So, it's a parallelogram, but that's okay. So if this is my trapezoid, right? So I have base 1, base 2. But if I take it, copy it, and flip it, all right, I create a parallelogram. And so the base is base 1 plus base 2. And so if you think about the area of a parallelogram, it's the area of the base times the height. Well, we only have one trapezoid, not two. So if I were to take the entire base 1 plus base 2, and multiply it by the height, that would give me the area of the entire parallelogram. But I only have one trapezoid, okay? And so half of the area of this parallelogram is the area of one trapezoid. Now, here's the reason I like to show you this. One, I think it's cool. Two, I don't believe you get a formula sheet on the AP exam, and so this is one you might need to know, okay? Yeah, I'm pretty sure you don't give a reference sheet at all. And so this is one you're going to need to know, and if this visualization helps you remember it, even if you can't necessarily remember it, maybe this will help you be able to generate this formula on your own. Cool. All right. I'm glad you found that useful. I hope you choose to use it. All right. Here we go. This is example 7. Okay. So they've already divided it up for us, and they've even drawn the trapezoids in. So go ahead and approximate the area based off of that table and this graph. Since the height is the x, right? And since the height are all the same, right? They gave us trapezoids of equal subdivisions. So you can do the same kind of thing with distributive property like I did with the first one for the height. You don't have to. Like if that's too confusing to you, don't find the area individual of each one.
Base 1 plus base 2 then, because if it cancels.
Well, it's half the height times that.
Wait, can we just
Because last year was like the first one.
Right. For each trapezoid, there's going to be a 1/2. For each trapezoid, there's going to be a 10 because the height of the trapezoid is 10. Each base, then, you have to add those. You'll end up with 4 sums. Because there's 4 trapezoids. So again, the thing that's nice is we know that each height is 10, and there's going to be a 1/2 in all of them, and so that's why I wrote it like this: the 1/2 times 10. Yes, you're right. You could leave it like this. This one is 1.8. This base is 2. Then I've got another 2, and then this is a 2.5. And then I got a 2.5 and a 3.5, and a 3.5 and a 2.2. Yes, this is enough. If this was a free response question, which seems like a really super easy free response question, but you know, maybe they want to compare and they eventually give you the formula for y, and they want you to, you know, calculate look at the left Riemann sum, look at the area of a trapezoid using trapezoids, then find the actual integral over this particular interval and explain why it's different, kind of thing.
Exactly, you have to put the integral or else you don't get the point. You can't have area.
Well, our problem is we don't have a function here.
Well,
So,
no, just integral f of x, yeah.
Just say.
so if I just went like this, I guess, they do tell us why. Okay, good to know. I think put the answer there. It is. It's approximately 100. There you go.
Look, I did it without a.
Good job. All right. So if we need the y there, then we will have the y, or I guess it would be y. It would actually have to be y of x dx. Anyway.